Okay, so we're recording again. Welcome to Geomorph 2020, our online version of the class, which I'm really excited for. I think you've all watched my intro video where I talked a little bit about my plans for the semester for you guys. I think there's some really neat stuff we're going to be able to do together. I'm really excited to meet a lot of you that I don't even know yet, so that's really cool as well. And the plan is in this remote education format that we'll be doing for the remainder of the term. My goal is for us to have a lot of individual meetings as well so that I can get to know all of you and we can talk a little bit about the class. So the goal for today is just to kind of introduce the concept of geomorphology, what we're doing here, and then kind of talk about what the format and what's going to be expected of you this semester. So that's the plan. So the first thing I am going to do is I've got two questions for you guys. I'm going to share my screen. And so now hopefully you're looking at kind of a background picture for the course. But I have two questions I want you to think about. And what is geomorphology, the class you're enrolled in, Geology 350, and why bother at all studying it? Why do we decide that this is something that you should know about? Because maybe some of you, but not a lot of you, are here because you had this deep passion for geomorphology that you've had all your life and wanted to learn a lot more about it. This is a required class in the geology major and a lot of our combined majors. So we, the faculty at Whitman College, have decided that geomorph is very, very important for you. So what I want you to do is think about those two questions, and I'm going to just pop you guys into some breakout rooms here where I want you to discuss amongst yourselves those two questions. What is geomorphology? It'll be neat to see what we come up with. And then two, why bother studying it? I'll just pop you into a room for a couple of minutes, and then we'll come back together and share what we've come up with. So how many of you are there? Okay, so welcome back, everyone. Would anyone like to kind of take a stab at kind of what they came up with for a definition of geomorph? Go ahead and just raise your hand. All right, let's go for it. Peter, what did you come up with?
Our group talked about kind of how it's like how water affects landscapes and how it's more like a broader like landscape-based science instead of looking at individual structures and cool. That.
Excellent. Yeah, so I like that idea of landscapes. Yeah, that's a big part of what we do. And it's funny, I think for a lot of you, that term kind of is intuitive to you. You know what a landscape is, but it's not for everyone. Some people, when I say I study landscapes, they think I'm talking about landscaping. And so, but no, landscapes, we're talking about the topography around us. Does anyone want to add on to what Peter said? Peter got it perfectly. Brandon, I saw you, I think you had your hand up. Did you want to add anything?
Yeah, sure. It's pretty similar. The way Henry explained it to me is taking, I guess, the larger processes we see around us and breaking them into smaller steps.
Cool. Yeah. Yeah, process is going to be a big part of this. Excellent. So I like that. How about with this kind of fuzzy understanding of what geomorphology is? Why is this a required course? Why do you guys think we're here today and for the whole semester doing this? Anyone else want to venture a thought? Carmen, yeah.
I guess it's important to understand how landscapes formed, because once you know that, you can extrapolate and see like how those processes affect other places on Earth, and you can if you're like interested in climate change, that's like a great one. And you can see how Earth has changed over millions of years.
Excellent. Yeah, you're absolutely right that um, that landscapes are influenced by things like climate change. And since we live on the surface of the earth in these landscapes, it'll be interesting. We'll want to know how they're going to respond to things like climate change. And as Carmen said, we can even use the geologic past as a window into what that's going to look like. And that's actually one of my research areas. I have some field sites down in the Mojave Desert where we look at climate changes over the past 10,000 years and 10 to 20,000 years and use that as a proxy for modern climate change. So excellent. Anyone want to add on to that? I think that's a good start. So what I'm going to do is I'm going to give you my 2 cents on trying to answer these 2 questions. And then we'll come back together and introduce ourselves, which we haven't done yet. So I'm going to share my screen again and show you some pictures. And I'm gonna ask for some thumbs up if things are working. So I'm sharing the last slide you saw before we crashed. If I try and make that full screen, all right, are you seeing this in full screen right now? Thanks, y'all. Okay, so this is what's in the news that I've seen over the past 2 days. Has anyone else noticed what's going on down in the Gulf of Mexico right now? It's hurricane season, and boy, oh boy, it's predicted to be an active hurricane season. So active, in fact, that there are 2 named tropical storms that are in the Gulf right now. Tropical storms Laura and tropical storms Marco. If you think, wow, that's crazy, I don't remember seeing that, in the news in the past. That's because it's really one of the first times ever we've had 2 storms of this size that are going to impact the same area within a couple of days. So it looks like Tropical Storm Marco is going to remain a tropical storm. It's not going to get up to hurricane strength, and that's going to hit somewhere in the Louisiana area. And then Laura, which is ravaging Cuba right now, is going to be churning along up and could reach with hurricane force winds to somewhere in the same region in the next couple of days. So this is going to have some pretty important effects on the landscape and on the people that live in those landscapes. And while we don't know what's going to happen with this hurricane, we've got some previous hurricanes that we can use to make some predictions about what's going to happen. One of the big things with hurricanes is it's not just the winds, it's not just the waves, it's the insane amount of precipitation that comes along with a hurricane, right? We're here in the Gulf of Mexico with really warm ocean waters, over 70 degrees. And so you can pack a ton of energy, a ton of moisture up into the hurricane and then dump that out over land. And so this is from Hurricane Harvey in 2017. And this one was just a couple of years ago. And this one was very famous for dropping in massive amount of precipitation in the Houston area. I don't know if you guys can see this right here in the center, but Houston got 43 inches of rain just associated with the hurricane. Just for comparison, you all have lived in Walla Walla now. That's the total amount of rain that Walla Walla gets in 2 years, just in a single storm. So that has some pretty important impacts on the landscape. So one of the things we saw associated with the hurricane was massive amounts of flooding in south central Texas associated with that. Here's some USGS crews, go USGS, woohoo, that were out there in the storm trying to get accurate data on the size of the flood. And it was big. It was really big. Can you guys see the before and after pictures here of this highway system? So here we have basically the interstate system that is now an active channel of the river. And not only were roads flooded, but thousands and thousands of people's houses as well. So here's kind of the track again of how much rain that was. So not only was there a huge amount of rain, but there was a huge amount of flooding associated with that storm. And so one question we can ask as interested scientists that are trying to mitigate the impacts of flooding events like this is, why was the flooding so severe? And interestingly, it's not just the hurricane itself, it's where the hurricane dumped water on us, on cities, on developments. And so Houston has some of the worst urban sprawl in the country. This is a picture from Houston. And when you put a bunch of houses and driveways and basketball courts and what else? Yeah, things like that on the landscape, roofs, all of a sudden that water that would normally infiltrate into the ground gets trapped at the surface and runs off immediately into rivers. And so by having low infiltration rates, how much water can go into the soil, we end up with this type of severe flooding. And just for comparison here, probably a lot of us don't spend too much time in Texas. What we're looking at here is I've overlaid blue. This is essentially the area of Houston that's been developed. And so you're basically looking at a parking lot that's the size of the Bay Area in California. So that's a lot of water, that 43 inches in every location, that would have, some of it would have infiltrated into the ground that then gets shunted into the rivers. And so for some people, when we think about why the flooding was so severe and why it left so many people homeless, it's not just the hurricane, it's a design problem. It's how do we design cities to effectively move this water away from people and away from infrastructure. And interestingly, I showed you that crazy picture of the freeway that was completely underwater. That's actually by design. Houston, the engineering strategy is actually to use highways as essentially ephemeral rivers during large flood events. But this storm was so big that even with these built-in waterways, it still was able to cause massive amounts of damage and tens of millions of dollars of damage. Okay, so what does this have to do with geomorphology? Well, I would argue that in geomorphology, we're interested in how surface processes create, inform, and modify landscapes. And so when we think about the problem in Houston, we need to understand kind of how the rivers that were there before there were humans there function, and how they function, and how we can keep them functioning with humans in the picture. And so, you know, we have to understand how a river functions naturally. Where is the stream channel? What's the floodway? What's the floodplain? How wide is the floodplain? Those are all variables we have to understand so that we can plan for large flooding events. So this actually is, when we think about landscapes, very much a geomorphology program of how we mitigate this type of flooding. Okay, so here's just kind of a view of a simplified view of what that might look like, where here we have, you know, a nice cross section of a landscape with some beautiful trees here, and then a floodplain, and then the active channel itself. And then we'll learn about this semester, that the floodplain we predict will flood every couple of years. And so how is that going to change when we go from a pre-development setting to a post-development setting, where we put a bunch of houses on the landscape? Some of those houses might be where we actually have floods, but also putting those houses on are going to put more water in the channel by decreasing the infiltration, and that's going to serve to actually increase the size of the floods. So these are all variables we have to account for when planning how we build cities. Okay, so yes, not only is it the precipitation, but it is absolutely the wind and the waves as well that cause massive changes to shorelines. So here you're looking at a before and after picture from a very famous, technically it was a tropical depression by the time it hit Jersey, but Superstorm Sandy back in 2012, which hit New Jersey and New York very, very hard. And so we can look at the before and after pictures and note the significant decrease in the beach areas as we've had a waves that eroded the shorelines and caused loss of property and cutting of roads and tens of millions of dollars of damage after Hurricane Sandy. So in Geomorph this semester, that's another thing we're going to talk about. We won't just talk about rivers, we'll talk about coastlines as well, as coastlines are probably one of the most active parts of a landscape in terms of how they erode. And because they're pretty, people love to live on them. And so we end up with a lot of human problems adjacent to coastlines. We have these highly variable transient landscapes that can change in a single storm, and then we get attached to our coastlines, right? Maybe you've seen pictures and news stories about some famous lighthouse in North Carolina or Maine that everyone loves because it's been there for 200 years. So we'll spend 10, 15 million dollars just moving a single lighthouse back away from a naturally eroding shoreline. So in Geomorph, we'll talk a lot about how these dynamic systems like coasts work. Okay. Another part of geomorphology is I want you to learn and think about how to read and understand a landscape, where we can look and kind of start to understand maybe processes that have taken place in the past that influence the landscapes around us we see today. Does anyone know where this is? Anyone seen this before? It's kind of a small photo, so I'm not surprised if no one can pick this out. This is the Grovant River. So this is the Grovant River. So this is on the east side of the Tetons, a river draining out of the Grovant Range and down into the Teton Basin. And boy, it doesn't look like a river, right? It kind of looks like a lake, which is pretty interesting. So if you're looking at this image, I bet a lot of you are already seeing, it looks like maybe you can see some evidence, right, of past processes, geologic processes that have influenced this river valley. Maybe a lot of you are keying in. By the way, can you see my cursor move right now? Is that something you're seeing? Yeah, okay, cool. You can see it looks like there's this cut in the landscape here and a big divot taken out of the side of the mountain, and it looks like there's some area up here that's not forested anymore. And then, down at the bottom here, there's a big pile of land with a bunch of trees growing on it. Yep, you're right. That giant pile of land down there at the bottom of the river valley used to be up here on the side of the mountain. And so this is a great example of a landslide, and a landslide that dammed the Grovant River. So this is called Slide Lake, or the Grovant Slide Lake somewhere else, sorry. The Grovant Slide, which happened in the 1920s, 1925, where we had a massive landslide that actually dammed the river, created a temporary lake, and then the water filled up that lake and eventually overtopped the lake, causing flooding afterwards. So here's a couple more pictures of the Grovant Slide. There's kind of what it looks like in winter. And here's what it looked like in 1925, right after it happened. So several people were killed in the Grovant Slide. And so in geomorphology, it's really important for us to be able to understand essentially how these landslides happen, where they happen, and why they happen, so that we can make reasonable decisions about how we plan and how we mitigate hazards such as landslides. Here's another aerial picture of the Grovant Slide, just a massive slide. And you can see the river being dammed up here, and then this is the channel it cut, the new channel it cut through the landslide debris. And here's a Google Earth image showing the Grovant Slide and lake today. So here is the picturesque Tetons kind of in the background here. This is essentially Jackson Hole down in here, and the Grovant River comes down and drains down into Jackson Hole and down into the Snake River. Okay. There's another way to think about the importance of geomorphology as well. We can think about how important it is to understand geomorphology and geomorphic processes in their relationship to ecology. And so here's a paper that was published a few years back showing how important debris flows are. So debris flows when you get this massive rock and mud and water that kind of gets triggered and dumps off a hill slope and often dumps down in a river. Here's the big boulders associated with these debris flows. Turns out that these geomorphic processes of debris flows are incredibly important for creating heterogeneity, so variability in what the river bottom looks like, which is actually really important for spawning for steelhead. And so a lot of us in the Pacific Northwest are really concerned about steelhead and other salmon species and their declines over the past several decades and what's caused them, whether it be dams, overfishing, or logging. So understanding the geomorphology and the spawning of salmon is really important for understanding that larger picture of why we're having salmon declines throughout the Pacific Northwest. Okay. Another part of geomorphology is we can do something called change detection, where we can look at landscapes and we can see how they've changed over time. Does that make sense to everyone, this idea of change detection? I've got a couple of drones I use in a lot of my research that we try and do this. We try and see, we take repeat pictures in the same place over several times, and we can see how that landscape has changed over time. So let's do that right here for this landscape here in Taiwan. Does everyone see it? Everyone see the picture? All right, let's see. I'm going to flip to the next picture, and we'll see if we can see any differences. So this is a picture taken from the same place after a large debris flow that was generated up valley and completely destroyed this village, killing over 5,000 people. So these tragic events, we can't prevent the landslide necessarily, but we need to be able to think about how we can reduce the hazards that these landslides present for people. So here's the Google Earth image of this location. So here is this river valley here, and you can see the very, very steep terrain in the background, right? Does everyone see that nice steep terrain back there? And so this was a debris flow that was generated very far upstream. And then basically because the debris flows are following gravity, there's nowhere for them to go but down valley. What's the problem with that? In a place like Taiwan, where you have very, very steep terrain, the only flat places available to build houses are at the valley floors, right in the path of the debris flows. So this can be tragic. So here's the before and after of this location where this settlement was completely buried in a debris flow. And so we as geomorphologists, we can use our understanding of landscapes potentially to help to understand these hazards and help to mitigate and move people away from such dangerous settings. Another view looking up the valley. Again, look at that steep terrain. You can see these landslide scars. See all these places where there's no trees? That's places where there's been previous landslides. And so these landslides and debris flows go down the drainages, down to this main stem where the town was completely consumed. Okay. So clearly, there's a need for us to understand processes that shape the surface of the earth, because human activities are located at the surface of the earth. And so we in geomorphology are in a great place where we can start to understand these processes and how we as societies can make better decisions to keep people and infrastructure safe. Okay, so now it's time for my definition of what I think geomorphology is. So I think the simplest way to put it is, I think geomorphology is the study of the evolution of topography, which is very similar to what you guys came up with at the beginning of class. What are the processes that have created this beautiful landscape you're looking at here from the Grand Canyon? Why are some places big cliffs? Why are other places, see these big cliffs back here? Why do we have cliffs in some places? Why do we have slopes in other places? What's driving these processes, geologic processes, to create this variability within the landscapes? That's what we study in geomorphology, this evolution of topography. If you want to do this well, and talk about process, which is really key. When I talk about geomorphology, we're often talking about process geomorphology. We want to talk about the processes that shape the landscape. And so our science that we're going to be learning is incredibly, incredibly interdisciplinary. If you want to be a good geomorphologist, you have to know your geology. You have to know the rocks. You have to know the different types of rocks. You have to know the difference between a granite and a basalt and how that's going to affect the strength of a hill slope. But you have to go beyond just a basic knowledge of geology. You have to understand water, right? You have to understand how rivers work. We have to go dip into the fields of hydrology. You have to understand things about how precipitation might change over time. You have to understand things like climate and climate change. So you have to have a little bit of climatology. Build on top of that, you have to have an understanding of not just the water, not just the rocks, but also the vegetation. So ecology becomes incredibly important for understanding how landscapes evolve as well. So that's one of the things that I love about this field, and one reason I've chosen essentially to become a geomorphologist is just that interdisciplinary nature, where we're going to be taking our understanding of the natural world from many different fields, whether it's hydrology, geology, ecology, physics, chemistry. We have to pull a little bit of all of it for us to gain a better understanding of how landscapes work. And the other part that I just find so really fascinating about geomorphology is that when we generate this knowledge about the surface of the earth, this isn't something that just gets buried in a library somewhere in some obscure journal that 50 people are going to read. Granted, there's some of that. I have some of those papers out there. But what I find important is that geomorphology allows us to make science-based decisions that affect civilization. How can we keep people safe? How can we keep people safe? How can we tell them where to build houses so that they're safe? We've got a great example of that from the tragic events of the Oso landslide in the Stillaguamish River Valley outside of Seattle, where we had a landslide a slump and landslide that covered a housing development, killing many people. And so with geomorphology, can we help city planners or planners to make better decisions about where we can build houses? Oftentimes when we talk about volcanoes, a lot of like keeping people safe from volcanoes, yes, it's the eruptions, but it's also the lahars that are generated after the volcanic eruptions. We'll talk about lahars this semester. And so that becomes a question of geomorphology, how we keep people safe from things like the delayed impacts of volcanic events like lahars. And finally, in this, the great acceleration that is climate change, humans and human actions are changing natural processes at unprecedented rates via climate change, via dam building, road building. All of these affect the natural world, and in geomorphology, we're primed to be right in the right place where we can understand those changes, how we can quantify them, and how we can mitigate the negative impacts of these to the best of our ability. Okay, so who am I? So I know a couple of you, but not all of you. I'm Lyman. You guys can just call me Lyman for the semester. I don't need any other fancy titles or anything like that. Lyman's totally fine with me. I used to teach out at the University of New Mexico Gallup, and everyone there called me Mr. Sir. It was really weird. But Lyman's fine. And so I was born in Vermont. I was born and raised in Vermont, went to college at the University of Vermont, and moved out to the West and the Southwest in New Mexico in particular to go to grad school. Kind of fell in love with the West and the landscapes of the West and the culture of the West, and kind of have wanted to be out here. Left for a job a few years back, and then came to Walla Walla about 5 years ago now, where I've been teaching geomorphology at Whitman. So I'm very happy in a part of the world where I get to talk about really, really cool geomorphology. And at a place like Whitman, I get really great students that are excited to learn about geomorphology and go out in the field and learn geomorphology. So that's kind of who I am. And we're running out of time for our first meeting. So I'm going to stop the share for right now and come back to our full view of everyone. So I'm in, I've got it in speaker view now. No, I'm going to go to gallery view. But what I would like everyone to do is, I'm just going to call on you, so this isn't mayhem, but I'd love everyone to just introduce yourself, who you are, what year you are at Whitman, what your major is, if you've declared a major, or what potentially you're thinking about as a major. And then let us know where you are in the world right now. Where are you going to be doing most of your semester? And that's kind of how we'll finish things up right now. So I'm just going to go across the screen to what I see. For those of you that are in Zoom right now, if you want to go to the speaker view, I think you'll be able to see everyone in bigger if you want to do that as we introduce everyone. So let's start on the upper left for me. How about Carmen? Carmen, you're on mute.
Thank you. I'm Carmen. I'm a senior. I am a geology major, and I am in Walla Walla for the semester.
Excellent, thank you. Also, I'm sure a lot of you know, but you can just use the space bar to turn your mic on and off, and that can be handy instead of clicking down to the mute button all the time, so the space bar works. All right, thanks, Carmen. And you're in Walla Walla, so you're a couple blocks from me. It's weird, but here it is. Okay, how about Ben?
Hi, I'm Ben. I'm from Boston. I am thinking of probably going to be a geology or environmental studies geology major, and I'm currently in Walla Walla.
Excellent, thank you, Ben. How is your sister's living in Missoula, right? How is she liking it?
She's good. I saw her like 2 days ago. She's doing good.
Good, awesome. All right, Brandon. You're on mute, Brandon.
Okay, spacebar didn't work for some reason. All right then. Oh, I'm Brandon. I'm a junior and doing ESGO major or combined major, and I'm in Huntington Beach, SoCal for the semester. Yeah.
Excellent. Do you have smoke down your way or nothing?
Not here, luckily, but we do have a heat wave right now.
Okay, cool. All right. Oh, and also, sorry, if I'm using a name, then you would prefer a different name, just holler it out for everyone as well. So thanks, Brandon. How about Zachary?
I'm Zachary. I am a 3-2 geology oceanography major. I am currently in Foster City, California. I get all the smoke. My weather app says the weather outside is smoke. So, yeah.
Sorry about that. Nice to meet you, Zachary. Okay, Henry.
Hi, I'm a senior anthropology major. I'm going to be a geology minor, and I'm in Austin, Texas.
Excellent. Nice to meet you, Henry.
That's me.
Okay, Peter.
I'm a junior and I'm a politics history double major and then a geology minor, and I'm in Walla Walla right now.
Okay, welcome. You've got the California flag in the background. Are you from California?
Yeah, I'm from Oakland, California.
Oakland? Okay, cool. Okay.
Yeah.
Thanks, Peter. All right, Mira.
Hi, I'm Mira. I'm a junior. I'm a bio-geo combined major, and right now I'm in Walla Walla. It's pretty fun.
Awesome, thank you, Mira. Okay, Annie.
Hi, I'm Ani. It's okay. I'm a sophomore, and I'm currently in Minnesota, but I'll be moving to Portland soon.
Cool. Portland, Oregon?
Yes, not Maine.
Not me. Okay. All right, Will.
I'm Will. I'm an ESGO major. I'm on Bainbridge Island, Washington. Good place to be, and I'm a sophomore.
Great, thanks, Will. Fielding.
Hey everyone, I'm Fielding. I guess as of like 40 minutes ago, I'm a sophomore. And I am from Northern Michigan, and that's also where I'll be for this semester. I'm undeclared, but I'm leaning towards environmental humanities with a geo minor, maybe ESGeo. We'll see. Good to meet you all.
Awesome. Thank you. Hey, Fielding, can you do the mitten and tell us where you live?
Yeah, thanks so much for asking. So here's the mitten, here's Detroit, here's like Chicago and Illinois. I am in the pinky.
Very cool. Thank you. All right, Maggie.
Hi, my name is Maggie. I am currently outside of DC in Maryland, and I am an undecided major. I'm leaning towards geology, and I am transferring in as a sophomore.
Excellent. Welcome, Maggie.
Thank
So
you.
you're from Maryland. Where in Maryland?
Bethesda.
Excellent. My wife is from Baltimore, so I've spent quite a bit of time in Maryland over the years. So, all right, Noah.
I'm Noah. I am a junior geology chemistry combined major, and I'm in Walla Walla right now.
Excellent. Thanks, Noah. And finally, Sharon.
Oh, hi, I'm Sharon. I am from Rwanda. I'm in Walla Walla right now. I'm a senior geology major, chemistry minor.
Excellent. Thank you. Okay, so we're out of time for today. So we're going to sign off here in a second, and we'll come back for our next synchronous meeting on Wednesday. And Wednesday is also our lab day. So we'll have class at 11. We'll take a break for lunch at noon, and then we'll get back together at 1 to start lab. I guess that's one advantage of you guys being remote, is that you get to just have your lunch at home and scroll TikTok or whatever you do during lunch. Generally in Geomorph, we often use the lunch hour to drive somewhere, so we won't be doing any driving. So we'll have our first lab on Monday, which is going to be introducing the 12 geomorphic processes that shape the surface of the Earth. And we're going to have a bit of a conundrum where we're going to go virtually to a place that's near and dear to my heart, the Big Sink. And we're going to take you through a virtual tour up there. Paul and I went and recorded video yesterday up there, or the day before. And we'll talk about kind of these central processes that shape the surface of the Earth. So that's what we'll do in the for our lab on Wednesday, and then on Friday we'll continue on. So we'll talk about how the course is going to run right at this beginning on Wednesday. That's what we'll start with, is kind of what to expect from the course this semester. I wanted to do this first just to kind of introduce why you're in a geomorphology class. I like to do that before doing nuts and bolts. So that's what we did. We'll talk about the course. I will also get up a first little mini lecture on part of chapter 2 that you can watch on YouTube through the Canvas site. And that's that. I'll let you know when that's posted. Right now, I'll still probably send a couple of emails, but we are going to be transitioning to be doing most of our communication through Canvas. We'll all use the announcements feature in Canvas to let you guys know what's happening in the class. And you'll be able to find all the assignments and all the readings on Canvas. But if you haven't got it already, you're definitely going to want to pick up your very own copy of Key Concepts in Geomorphology, Bierman and Montgomery. So you'll enjoy reading this one. I think it's the best geomorphology textbook there is out there. You might even see a picture or two of me in the book. I know they're in there, so keep an eye out for those. But this is a very well done book. I'll talk about why I like it so much on Wednesday. But definitely get your hands on this and have a look at the first half of chapter 2 for Wednesday. And that's kind of what we'll be talking about after we go over the nuts and bolts of the course. So sorry we ran a little bit over today. Can I answer anyone's pressing questions right now? Does anyone have any burning questions or burning thoughts or a haiku they want to share with us? Not yet? Okay. Well, I always like it when people share haikus, so keep that in mind for the rest of the semester. Okay, well, that's it then. Thank you all for coming today. Thanks for bearing with me with a little bit of technical difficulties. I'd like to say that it'll run smoothly from here on out, but you guys know as well as I do that this is we're all just kind of learning this as we go and dealing with technology. So that's our plan. Thank you all for coming, and shoot me an email if you have any questions between now and Wednesday, okay? All right, thanks all. We'll see you soon.
Thanks, Lyman.